So we are going to have a major uptick in adoption of this technology in the next 3 years. And I say that because it will be driven by big infrastructure choices that utilities have to make. They have to replace aging meters. They have to upgrade transformers and various equipment on the electric grid. And so when they make those decisions, I think what we've started to do in collaboration with our early adopters is help utilities understand that they need to make a choice about the compute that's inside that infrastructure, and they need to make decisions about how they're going to run AI models on the grid.
Your trusted source for information on the energy transition. This is the Insider's Guide to Energy podcast. Energy Insiders, welcome to Insider's Guide to Energy. This week we have an exciting episode talking about AI and what that means and where it should reside in the utility and energy industry. Our guest today is the COO and president of Utilidata, Jess Melanson. Jess, welcome to the program.
Chris, thanks for having me.
Well, I heard in your opening statement what your vision is. You and I met, a couple months ago now, and you showed me some prototypes, and you got me really excited about what your idea for where AI lives and what it does. I think it makes sense to maybe start by telling our audience a little bit about what you guys are building and what you're doing.
Yeah, so we've built the first AI module for the electric grid, and it's called Karman. That's the name of our module and our platform. And when I say for the electric grid, I mean we've customized a product to run AI models on the electric infrastructure. And so what that means is we took an NVIDIA processor, and NVIDIA is our partner in this product, and we've customized it. So we made it smaller and lower cost. We made it cooler. It operates at a lower temperature. It uses less energy. And so we've done all these customizations to take a processor and make it more rugged and allow it to operate on the electric grid where things, devices are out there for a decade, 2 decades at a time in extreme temperatures. And the other thing we've done is we've added a layer of industry specific software to that module. So we take all that really granular, complex waveform data that many devices capture on the grid, and we make sense of it. We put it into context, we filter it, we make it usable to a platform layer that allows Utilidata, but importantly, anybody else to build AI algorithms and models that live on that module. So it's a customized AI based module for the electric grid, and it can be embedded in hardware, other people's hardware, not Utilidata's, not NVIDIA's. And so that's the product. It's a first in the industry, and our goal is to really transform the way utilities are able to buy, compute, and invest in AI for their infrastructure.
All right. So you managed to get just about every cool buzzword in your opening statement there. And you got some cool brands like NVIDIA doing stuff with AI. So got everyone's attention. When you say in the electric grid, that's a pretty broad statement. Help us understand what AI in the electric grid means. Where does it live, and what are these chips that you're doing? Where are utilities putting these chips?
Yeah, so what we focused on the edge of the grid first, and we did that for two reasons. One, that is where the most of the emerging complexity is on the grid, and so you guys and your listeners obviously know that distributed energy resources and storage and generation and things that are showing up at the edge of the system that previously weren't there, obviously, and that the grid had not needed to be concerned with. Um, and the second thing is that's the area of the grid where utilities had the least visibility and the lowest they lack tools to manage all of that. So we started at the edge, and we're embedding this AI module in electric meters. Having said that, this module can live at any part of the system, and really it can be useful to anything that electricity runs through. But we've started with utilities, and we've started at the edge of the grid based on our experience as a company and the needs of our customers.
Jess, can you tell us more about what you think the killer app is? as in the application where you're going to use AI and this complex waveform data to deliver value to the end user?
Yeah. So there's three broad categories that utilities who are early adopters are looking at when they adopt this technology. So the first bucket is distributed energy resource integration, and I'll talk a little bit more about how AI helps there specifically. But it's this full range of seeing where DERs are, understanding what they're doing to the grid, predicting what they'll do next, modeling different scenarios, and making a recommendation for a better charge discharge, uh, uh, execution for DERs. So that's one big bucket. The second, I would just broadly call visibility. Chris, you were impressed by my buzzwords. I'd add digital twin to the list. Um, but just this ability to sort of understand their assets at a granular level and get a better sense of their capacity, their health, their usage, et cetera. And then the third category, which I do think could prove the most valuable of all, is anomaly detection, understanding what's going wrong, being able to see in the waveform things that are indicative of equipment failure or pre-outage conditions. And obviously, job number one for utilities is reliability, and so that could be really transformative. Um, any one of those categories of benefits pays for the device itself. But the benefit and the beauty of investing in significant compute and an AI based module is that you don't need to stop there. I mean, we've already discovered things we didn't realize we were going to find in that data. And so part of what we're trying to lead utilities to with this product is the ability to keep doing more and more. And so that hasn't always been present in grid mod investments. And um, so those are the first areas of killer apps. But in our mind, the real sort of killer capability here is just the full range of AI models that utilities and many of their partners are now going to be able to build right there at the source of the data.
How is this different from maybe a smart meter strategy or a strategy where I already have some apps that run at the edge of the meter? How is this technology, and is it overkill, or is that what we need to be doing today to meet a transition of energy?
Yeah. I mean, we firmly believe it's the latter. We are obviously betting on more compute, and we're betting on AI being a transformative technology for the grid. But that is certainly the debate, right? There are technologies out there that offer less compute at lower cost, and they say that they're sufficient for the use cases that we're looking for. So it's really up to the customers and the market to decide. But we feel very confident as you look at not just the utility landscape, but other industries. Obviously, AI is transforming other industries. And I know our minds, or at least mine, always goes to language models and chat GPT, which is the most sensational version of AI that we see in our lives. But there's all the sort of assist capabilities and human AI interactions that are really, whether that's in our navigation systems on our phone or in our cars or in the Amazon warehouses that allow us to get a product in a day, um, that are already out there. And so that's more analogous to what we're talking about on the grid, which is this evolution of tools that helps utilities see things better. So I'll just use an example of electric vehicles. Know where all your electric vehicles are in real time and know where they're plugging in. There are ways to figure that out today with centralized AI, with data, with customer programs. It's not going to be as complete or good, but you can get an approximation for sure. Um, but what AI helps you do is evolve that capability over time. So it's going to learn and get better and better and better much faster than your other types of applications. And it's learning from data right there at the source. So you don't have to pay a huge data transmission and storage cost to keep training that model and keep having it improve. But then you can really keep progressing to what is that EV doing to power quality at a local level? And at the University of Michigan, we've already found some surprising things about how different chargers and vehicles are negatively impacting voltage levels on the grid and could cause reliability challenges. So you get to this deep understanding of the operational impacts of an EV. Then you can start to predict behaviors. You can model multiple scenarios. What happens if your heat pump and your EV turn on at the same time? So you have that digital twin capability that evolves. And then you can optimize assets, figure out what a better charging schedule might be given all that you know and all that you can predict. So we started EV identification. Yep, lots of people are going to say that. Someone might say I can buy a cheaper processor and achieve that goal. But if you want a native AI capability and you want the ability to run that full spectrum of capabilities, you need a really robust module. And I just went through EVs. You could talk about solar heat pump, you could talk about resiliency, you could talk about transformer loading. There's no end to the models that you could run locally. And so, what we're really selling is the ability to have a software defined AI enabled infrastructure, which is quite different than, say, AMI 1.0, which you mentioned.
Now, AI is still early, right? I mean, we've been doing, I guess, when I was in university, we were doing machine learning and things that would be called AI today. But for where people are going, you just gave some interesting um, antidote of what could be. So, is this a tool that will be used by utilities to go and adjust rates? And you see that the AI will help change like how they're asking for approval to get higher rates for ratepayers and things like that? Is that part of what this will be used for?
Um, I mean, I think it'll be used for a more informed discussion on all sides, right? There's a lot of guesswork and estimation in things like interconnection. That's why it's slower. That's why it's frustrating for many parties. Um, there's a lack of information. There's some kind of uh, poor, low data scenarios being run about what will be the impact of this system on the grid, for example. If you have AI based infrastructure, you don't have to really guess about those things nearly as much. You have visibility into system conditions. You have predictive models that can uh, help you understand what's going to happen next. And so, in our view, the way that AI is going to impact things is more subtle than like, suddenly the robots are talking about the rate case or whatever. It's more like, it's not autonomous driving where you go to sleep at the wheel. It's lane assist and brake assist and this evolution that helps make things that the humans are already in control of, um, make them a little easier, make them a little more a little better informed. And so that's sort of the way we think this is really going to start to hit the regulatory realm and just utility operations and planning. Is just a lot better information and predictive capabilities on their infrastructure.
For those at home playing buzzword bingo, I have one more to add, which is transactive energy. So we've talked about information out, maybe from the edge to the utility, obviously with your inherently safe distributed architecture where you're doing the compute locally. How much of this could also be control signals or pricing signals? And to Chris's point, a lot of the smart meter 1.0 was, hey, now we have 15-minute interval data so that we can charge you on a time of use basis, which is maybe not the great feature that everybody wants in their home. But the promise here is maybe doing that where you don't have to pay extra attention to the rate and you can have two-way communications, and if not a direct control signal for like a demand response event, at least a price signal. How much is that included in the scope of your vision?
Yeah, I think that's sort of the end state of those DER management tools that I mentioned earlier. Um, but it is the end state in that I think when we've tried to do transactive energy pilots and things before we had the data and infrastructure and control architecture to do it, um, it ends up stuck in pilot land because the scalable model isn't there yet. And also, where it falls down is, well, what's the customer? How does the customer engage? What's their incentive structure? How do we keep various parties, the DER companies, happy about this? So it's hard. It's hard to pull off. It's sort of a end of the evolution or toward the end of the evolution state of things. But this type of capability that we're talking about is foundational to being able to do it, and it helps you along that path. And again, this progression of, um, to do transactive energy, you need to know the state of your grid. You need to know the state of the assets. Both sides. The customer needs to know it, but the utility needs to have a sense of it as well. You need to be able to run better scenarios. You need to understand local conditions. FERC has required this of utilities. And then you need to communicate that and get the feedback loop of what happened. Um, Even in more simple DR that feedback loop is pretty bad, right? You have aggregators who wait a day for the information about what happened. They don't know which customers to nudge further or not, right? So there's all kinds of sand in the gears of this progression toward transactive energy, that the root cause of which is poor data, poor visibility, and pretty latent understanding of what's happening. I've been talking a lot about distributed AI, and I just want to zoom out and say that there's these features of having the AI running on the architect, I mean, on the infrastructure itself, that are really important. It is faster. Um, it is lower cost because you don't have to ship all your data back. There's a resiliency element there because it can operate, at the edge if it loses, connectivity for a period of time. There's a security element, as we talked about, and then there's just a results element. Like if I'm doing DER forecasting, solar forecasting, for example, an edge model that can understand more quickly local conditions and model those is going to be better, give you better results than if you're waiting for a kind of a centralized view of things only. So this distributed piece of the AI architecture is really important, especially for critical infrastructure like the distribution grid.
That's great. And what love about this as well is there's a deep lineage here. So Utilidata as a company goes back to 2012, I believe. You've been there since 2018. So this is not a rogue band of coders spinning out of OpenAI to try to figure out what other data they can feed the machine. This is coming from people you've been working with utilities for over a decade. It's from those deep relationships, customer engagement, understanding of the sector, that you're building something to fit a need. Can you talk about what the first generations of the company were focused on and what led to this being the new focus?
Yeah. Yes, you're absolutely right. We started this company over 10 years ago, and the first product was a machine learning based voltage optimization software package that ran at the substation. And so the underlying premise of what we did is the same as today. How do I take all that grid data in real time, make sense of it, and use it to make better decisions? And so we did that in a very operational context. That software is still running today, and it decides the voltage levels at the substation and on down. So that is both a very hard, uh, it's hard to earn utilities trust to allow software to make operational decisions. So that took a lot of time and growth to be able to do that. But it also gave us this sort of unique skill set of how do you make sense of all this data? How do data scientists and software programmers take, you know, current and voltage and turn it into better outcomes? It's a unique skill set, and we were applying machine learning and AI to that data way before most people that we ever ran into. So we were pretty early to that front. So we have this DNA of being able to understand grid data and being able to turn it into grid outcomes, and having trust with utilities that we get their business, we understand their stakeholders. We have a lot of folks who worked at utilities and worked at the regulatory commission, and so you just earn an appreciation for why it's so hard to adopt new technology in this industry and what constraints utilities are facing. And so, with all that experience, we gravitated toward the edge, and we decided we needed to build our own platform, compute module for the grid. And we found NVIDIA as a partner in that. And they had a wonderfully relevant skill set that was totally different than ours, right? They've transformed industries across the globe. They are the undisputed global leader in AI and accelerated computing, but they didn't understand the electric grid the way we did, and they didn't understand utilities and their regulatory constraints the way we did. But they saw the exact same thing, which was infrastructure that needed to become AI enabled. And so it really was a perfect partnership and marriage of skill sets. And so with this custom module we're building, and our first hardware integrations, that's now exactly what we're doing together.
I feel like the conventional wisdom from venture investors would include things like don't rely on federal funding. We can't invest in businesses that sell to utilities. You've proven an ability to scale despite the naysayers. Is that still good advice to startups or aspiring entrepreneurs listening today? Or is there something where, hey, actually, if you do it right, selling to utilities actually isn't that bad?
That's a great question. Well, it's not for the faint of heart. I'll say that. Um, You know, for us, this is just the space that we collectively know. Like I worked in a utility for almost a decade. You know, we've all, a lot of us have worked in this space, so it's kind of what we know. So we sometimes say if we can't sell AI to utilities, no one can, and so that's kind of for better or worse what we have set our sights on as an organization. We're very mission driven. We're very climate mission driven as an organization. And so, really, what gets us up out of bed every day is the idea that this infrastructure has to get smarter. It has to get um, lower cost. We can't just rebuild everything, at the cost of tens and tens of billions of dollars in every jurisdiction to get ready for this load growth and this complexity. And so, um, you know, sort of like somebody has to do this, and we feel like this organization is really well suited to do it. I will say to your question about investors, obviously the utilities are really hard to sell to, but once you do, they buy in very big scale. And if you can really prove a new industry standard, they don't compete with each other; they standardize. And so we do think this bet that an NVIDIA based module, which is the lowest risk AI infrastructure to standardize on by a long shot, is actually a risk mitigating investment for utilities. It is the lowest risk, most responsible way for them to start to get into AI enabling their infrastructure. And so, that's what, and we have a really good set of investors, which include NVIDIA and Microsoft and companies that take a pretty long view of AI and industry transformation. And they see the same thing. This is going to happen, and someone's going to figure it out. And they've placed a bet on us that we're going to figure it out with our utility partners.
We've talked so much about utilities. It's clear that you have a depth of understanding, and this really comes from you've spent over a decade working in and around utilities, and before that, you have a background in a different kind of public service. So, tell us about your personal journey before Utilidata, how you came to better understand and kind of really be an insider in the utility sector, and how that's informed what you're doing today.
Yeah, so I went to public policy school and I worked in the public sector, and I was a policy generalist, and I was working for the governor of New Jersey as a policy advisor, and they handed me energy on my first day on the job, which the beauty of being a 20-something-year-old in a sort of a political policy job is there's no experience required, substantive experience required. So they just handed me this area. Um, and I just was hooked on it because it touches everything. It's economic development, it's health, it's environment. Um, it's really complex, and it's essential. It touches everybody every single day, and in increasing ways. When I started 20 something years ago, we were not as reliant on electricity as we are today. I mean, everything from the internet to charging your phone to now charging your vehicle to your heat. Um, we are really, really, as a society, for good reason, getting deeply invested in electricity and the electric grid. And so, from the standpoint of wanting to make an imprint on the world, I feel like when I talk to policy students thinking about what area to specialize in. Um, I just think it's endlessly fascinating, and because it's at the center of climate change, we need all the smarts and dedication we can get. And so, um, it's a really unique industry, and I think um, utilities are certainly often misunderstood, especially by technology vendors who are trying to sell them new tools. It's not easy to take a chance inside of a utility. It's not easy to adopt new technology inside of a utility, which makes sense. They deliver to customers deadly products that need to have constant, reliability. That is a very difficult thing to do, and their economic structure says that doing something imprudent is about the worst thing you could do, right? So we totally understand why it's challenging for them to adopt new technology. And I think that understanding helps us collaborate with utilities, because we're not coming in there saying, come on guys, look at all these other industries using AI, you're just behind. We get that we need to make a case to regulators together, and that we need to talk to DOE about the importance of helping accelerate this type of technology. And so for me, just having kind of grown up in the industry, I think it really helps what we're doing, that so many of the folks at Utilidata have done the same thing, and they understand the partners we have to work with to get this done.
All right. As we bring this together, we're up at time. I like to have a crystal ball question. Um, and in your case, you're bringing new technology out. You've got this NVIDIA chip. I guess the question I have is, how soon do I see this mass adoption of this technology? I mean, obviously, as your role in your company, you would love it to be today. You're still early. 12 months, 24 months, 36 months. When am I seeing this across major utilities?
Um, so we are going to have a major uptick in adoption of this technology in the next 3 years. And I say that because it will be driven by big infrastructure choices that utilities have to make. They have to replace aging meters. They have to upgrade transformers and various equipment on the electric grid. And so when they make those decisions, I think what we've started to do in collaboration with our early adopters is help utilities understand that they need to make a choice about the compute that's inside that infrastructure, and they need to make decisions about how they're going to run AI models on the grid. And so there's a forcing function here, right? It's not like we just have to go door to door telling utilities, here's the Karman module. They're making big decisions, and the utilities we work with understand this. They understand that the choices they are making in the next 2 to 3 years about how, where, and how, and what to buy on their infrastructure are going to determine whether or not they become a bottleneck for this energy transformation or not. And so the stakes are pretty high. I should mention one more thing, which I didn't mention. Our hardware partner, our first adopter hardware partner, which is Hubble. And so we're embedding this module in an Aclara meter. And Hubble is a company that makes almost everything you see on a distribution grid. They make all this equipment. And so, the other reason I'm confident in the accelerated adoption of this technology is we have great partners. NVIDIA stands really strongly behind this. They are going to produce the modules with us. And these hardware companies like Hubble are going to produce really reliable hardware. And we're just going to put this technology together and give utilities a lot of choice, and, much more of an AI easy button than they've ever had. And so we think that the adoption is going to really accelerate, both as they make those technology investment decisions and as they see the adoption or the use cases and the applications that start to develop over the next year or so. If you put those two things together, we feel really bullish on the pace of adoption.
Jess, thank you so much for the conversation today. I feel like this has really been an insider's guide into the interface of utility decision making, the next generation of truly smart meters. And we covered a wide range of applications: voltage management, rate design, M&V, distributed generation, EVs. We touched on all of it with a new lens of how hardware is going to improve the lives for ratepayers and also utility program managers. I can't imagine anybody else giving us that kind of guided tour through so many different topics. On behalf of our listeners, thank you so much for joining us today.
Thank you. It was a great conversation.
Thanks. For our audience, we hope you've enjoyed this conversation. If you enjoy what we do here at Insider's Guide to Energy, please like us, subscribe to us, and follow us on YouTube. That helps us get more guests. It helps us bring the content you want. It's the best thing you can do to thank us for bringing you this content. And we look forward to seeing you again next week on the Insider's Guide to Energy. Bye for now.